Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Future Friday, we're going to talk about great techs and scams of India. So let's dive deep into it. Now you have to understand it. What does it mean India right now? Well, it simply means world's most populated and is on the planet Earth, the most populated country in 2025 is India. Now to give you a context, what kind of numbers we are talking about? Well, you take India and China, you yeet 1 billion people, the remainder still would be more than what America has, which is the third largest population country. So fundamentally speaking, we are talking about huge population, like bonkersly huge. And there is another aspect of it. For example, USA and China surface area wise are huge, like multiple square kilometers. They are like huge, exponentially huge compared to India, and India has all that in small place. So just by sheer number, what does this number means? Well, we have lot of genius, like lot, not one or two. Like you would be shocked how many genius people we have, like shocking. Like if you take colleges and best of the best of the best and filter them out, like you really want, and you will understand in 5 minutes later why so many CEOs are Indian origin. It's like we have good, capable, competent, intelligent people in droves. It's just that we have so many average people that is just like, it feels insignificant, but no, we have it. Like Rabindranath Tagore started winning Nobel Prize in 1913, and Nobel Prize in Physics, C.V. Raman won that in 1930. We are a very healthy country when it comes to intellectual horsepower. Like, we're good, we got this. And we have been doing impossible things regularly. Right now, Indians bitch that we are not first world country. Yes, right now there are 200 countries on this planet, almost 193, 197, just go with 200. At this point in time, there are much larger number of countries that you do not want to be in rather than be in India. And even in USA, people are coming from USA to India to get medical treatment. So generally you have to understand, many of these first world country, they give you a perception because you are looking at their best of the best of the best on social media and all that jazz. So it feels like, oh, everybody's like, nah bro, nah, they have crisis, like serious crisis. And it's not like, oh, Indian people have poops in the street. Like that's the same as New York, that's the same as California, that's the same place as fentanyl craft, capital, so to say. So fundamentally, you have to understand, we have been doing impossible so regularly, we do not even give a damn about it. It's like, oh, like, again, that's why I specified that India does have much smaller surface area. At the time of our independence, we do not have a very concrete data, what was the population size, but everybody in, European empire and even USA and all, everybody was like, they're not gonna last, they're gonna die. It's like, without East India's company or basically British Empire managing it, no, we survived. And we thrived. This is a very recent thing. We thrived. We are feeding 1.5 billion people. I was like, no, you're not feeding. No, people do not run on photosynthesis. People run on food. And at this point in time, as in like in 2025, if there is an Indian who is not getting food, it's generally a management issue rather than, oh, we do not know how to make food. Like, we good. We are not Africa. We good. We got this. Every problem, like our first generation, they got the country together, laid the foundation of a healthy country. Second generation, they worked their ass off to solve every issue. We had green revolution, like turbocharging our agriculture output. We had white revolution, milk, turbocharging the milk output. Brick by brick, day by day, we solved things that was unimaginable by all these countries. Like, you can read the report of like what the news happened, like, oh, India got its independence. You can read the news report. Everybody was like, yeah, they did it. And again, compare this to same time African nations that, like, it's like, now you will understand, oh, fourth in terms of GDP is like, whoa. So fundamentally, we have been doing the impossible so regularly, it's like, meh. Like, for example, people who say India does not have like good tech infrastructure, our railway infrastructure handles so many people. If you feed that much ticket data, almost all servers will be like, what the hell are you doing? So we have been doing impossible things for like so long. We have space program, better space program than UK. So let that sink in. We have been doing regularly. And again, it's like ironically a good thing that we are bitching that we are not that good. Like, we are so healthy that we're like, we are that good. Like right now, if you are in South Africa, people are like, can I have electricity? And India is like, dude, can I have 24 hours electricity? Like, we do have electricity. Almost all places have electricity, just that some places have poor on time. And since we are going YOLO on solar, that's also not an issue. So we have been doing impossible regularly. And here's the problem with this large number. And if you have democracy, 1% failure looks like catastrophe, and yes, it is. Like, mathematically speaking, if you have like 3 or 4 times the population, 1% will make such a huge amount of mess. And the fact that we have surface area is small, it makes it look like catastrophic failure. So that's a mathematical reality. Basically, if 1% of Japanese people are not nice, let's just put it that way, you can still crawl your way through it. If 1% of Indians are not nice, you're dead. So fundamentally, we actually have to be on much better behavior, and we are doing reasonably good, like reasonably good. So fundamentally, the scale involved is magic. So we have been doing awesome things for long enough time. And there is a tiny problem. While we do have a lot of genius, we also have a brain drain problem, meaning a lot of geniuses here leave this country. So that creates a unbalance. So it started out with good, large population, good balance, then it slowly happened. And again, you will see bell curve. That's not an accurate description of intelligence. Accurate description of intelligence is what we classify as Pareto distribution, as in utilizing the intelligence you have to do something productive for yourself. And in that regard, that top 10%, losing even 1 or 2% of that can destabilize a country. So we are very vulnerable to scam. Even though we have been doing amazing things, miracle things, you can sell Indians a scam like there is no tomorrow. Like, that is very, and again, in the name of progress, because so many people are in that bitching era, that you can sell anything. So I'll give you 2 examples of awesome technology that India has, and nobody talks about it, and to BS technology, everybody talks about it. So plastic pyrolysis. Now here's the deal. India used to have a lot of festivals, foundation. We used to have, like, villages and all that. There was a mela, like, a lot of people will get together, there will be a party and all that. And it was a mess. But here's the deal. That mess self-cleaned itself. How? Everything we were using, basically every bowl, every food plate, it was made out of leaf, biodegradable material. So we did not have to worry about it. We just let it be. And nature was like, okay, give me 1 month, shift delete. We did not have to worry about it. It just became fertilizer. Or if a farmer had to reuse that land, they will just collect it, put it in a pit, forget about it. So we went from that to plastic. And problem is, plastic does not follow that rule, and we did not have protocol to handle plastic. Now, to be fair, whole world did not have it. So fundamentally, plastic is too cheap. What does that mean? That simply means it's useless to be recycled, meaning you can only recycle something if it has value. Like, you can recycle aluminum, because again, mining aluminum is very expensive and intensive. So recycling aluminum, good. Recycling steel, good. Recycling glass, good. Recycling plastic, no good. Why not? For example, where does plastic come from? It comes from oil products, meaning India buys crude oil or kacha tel from a lot of nations, be it Russia, be it OPEC, be it Venezuela, all other states. We are buying a lot of them. Now here's the deal. We are buying it regularly. So even if oil and diesel is being consumed and you're like, okay, we are recycling 100% of the plastic, let's just go with that. What the hell are you going to do with that plastic stock that is still being created? So for that reason, plastic prices are always low, because we are consuming it and it's a byproduct. So that creates a scenario where the supply and demand is not matching. You cannot recycle plastic no matter what you do. So how the heck that plastic, that was a scam. That was a very amazing scam by multinational corporations, giving brain damage to nations, almost half of the planet. So that created a scenario where plastic became a waste. You're not going to spend, like, for 1 cent of plastic, you're not going to spend $10 to, like, collect it and transport it and then have a plant to deal with it. That's not going to happen. And that's why we have microplastic catastrophe. It's not going to happen. Like, how the heck people got convinced of that is beyond me. But thankfully, science and chemistry has an option which we call pyrolysis. And pyrolysis is simply basically a pressure cooker where you cook this puppy without oxygen. Now, you can cook it in vacuum depending on your requirement. You can cook it in argon depending on your requirement. You can cook it in nitrogen depending on your requirement. As long as there is no oxygen, you're good. So what does that do? Well, plastic does not break down. That's the problem with it. We wanted a miracle material from scientists. Scientists gave us miracle material. It's just that we forgot to close the loop. So what happens to plastic? Well, let's say you have plastic bottle like this and it goes into the sun. Now, sun has this naughty puppy known as ultraviolet. Ultraviolet will break it, but here's the, all it will do is break this object into micro object, meaning this microplastic. So it does not get removed, does not get dissolved. It becomes a poison. However, in pyrolysis, you are doing something tedious. You're doing it and you're cooking it. What does that mean? It's basically distillation. You are taking a very long, stable, solid state, long hydrocarbon chains, let's say C50, C60 kind of series, and then you're cooking that puppy. And then you're breaking it into smaller hydrocarbons, which would be liquid in room temperature. So you will go from C50 to C60 to C5 to C20. So you are getting what we classify as pyrolysis oil. Now let that be clear. Pyrolysis oil is not like a biogas where it would be CH4. It will be classified as a super material, meaning it will have C5, C20, C6, C7, C8, all of them. So how much of it, that depends on feedstock. Basically, if you are fitting a lot of chips wrappers, they will be different. If you are fitting a lot of bottles, it would be different. So you will get in that zone based on the temperature you are cooking and based on the material, and it will behave like diesel oil. Can you use it in your engine directly? Yes, you can use that. Although it's not recommended, simply because whenever you are buying diesel from fuel pump, it's not naked diesel. You're not just getting diesel. That's not how it works. You generally have a lot of additives, from corrosion inhibitors to basically octane boosters, or that's in case of petroleum. I forgot what it was called. Cetane. Yeah, cetane boosters and all that jazz. And then you have basically detergent to clean the fuel injector and all that. So if you remove all of that, your fuel computer would be like, what the hell is happening? And be mindful, this is a very messy soup. It's not quality controlled. So you could have like fuel injector is like tweet, kaboom, to be like, bro, I'm not getting it. So there is a bit of mess there. So can your engine run on it? Yes. Can it survive it? Yes. Should you do it long term? No. So what can we do? Let's say you got the pyrolysis, you took all the plastic waste, converted into pyrolysis output. What can you do? Well, this is a perfect, what we call feedstock, meaning you take this, you send it to oil petroleum companies. What they do, they basically blend it with their cooking tower, so to say, and output diesel. So basically it reduces basically it's a recycling. You just have plastic as a recycling. It improves, reduces 1 to 2% of fuel consumption. So as in like crude oil requirement. So a good thing. Or you can do direct use in some cases. For example, if you have a generator on site, you can use this. You can use this without any issue. And if you are in industrial customer where you need fire, shut up, take money. Shut up, take money, go home. And it's actually burns cleaner than normal diesel, simply because it does not have that much sulfur content. However, not all plastics are comfortable with this. For example, PVC does not like it because PVC has what we call chlorine by mass a lot, not like 1 or 2 molecules of it. No. By mass, it's bonkers amount of chlorine is there. So that is no. Now, can you handle it? Of course, you can handle it if you want to. Generally, people are like, yeah, put PVC on something different. And PET is also not that comfortable. Nylon is a messy one. It can be sent through this. It's just like you have to tweak it, have some catalyst that is doing some love work to it. Messy things. But again, normal polythene, basically plastic wrappings and things of that nature, you can just digest it like there is no tomorrow. Medical waste, digest it like there is no tomorrow. And India has many projects of it. Like somehow Indians are smart. Somehow Indians have made it. This is in Bihar. Now, if you do not know about it, that state generally has very bad reputation. And if I'm talking about optimistically, it has a reputation where it's like either you're going to be a genius. If you are Bihari, you are going to be a genius, or you're going to be an idiot. There is no in between. So even Bihar has it. Now, I do hate basically news media. They always talk about it as it's a new thing. India has been slowly building it up, but we haven't created a collective intelligence about it, where it's like, oh, this is a thing. We started like 7 years ago in South Indian state, Karnataka, I think. And then we started a certain place, Hyderabad, let's just say 5 years later. Then we did this is 2 years later. So we do not have like a cohesion where it's like, oh, India has this technology. We have been developing, bring back more and more states. So government actually can solve a plastic problem. All they have to do is remove all the subsidies from recycling plastic to local pyrolysis. You cannot transport plastic. I have no idea how the heck that idea even came to be, but you cannot transport plastic. Plastic has to be collected and just kaput right there on the spot. And yes, this technology is super cheap. These are students who built it, and it actually works. Like you can easily build 1 ton per day plastic digester very easily. So we have the technology. People have been working, and nobody talks about it because this is awesome. That's the ironic part about good technology. It's like nobody talks about it because it just works. Now we come to my personal favorite technology, which is LTTD. Basically, this puppy is what we call low temperature thermal desalination. Now, if you know planet has water crisis, and you would understand like India would also have water crisis. Well, no, not really. If we have water crisis, simply means we have stupidity, not that we have water crisis. So planet has infinite water. Because of water cycle, no matter what you do, water will be there. You do not have to worry about it. However, most of it is in ocean, and that puppy is salty. We do not like it. So that's an issue. Now, okay, why not just desalinate it? Well, we can, but generally you will have a triangle to deal with. You will have brine as an output, you will have power requirement as a drain, and you will have cost of the system. You have to deal with two of them. Like for example, if you deal with RO, reverse osmosis, you're gonna get brutal brine, you will have lower power consumption, but you will have ludicrously high cost. If you go to Saudi Arabia, you will have a bonkers power consumption and bonkers cost, but brine would be less, not zero, less relatively compared to RO. RO is worst, multi-stage desalination is least, and this puppy, low temperature thermal desalination, it has none. Basically, it's cheap, does not consume power that much, and brine wise it's negligible. Basically, from She's point of view, it's almost like that day temperature was a bit higher, nothing more than that. So this was developed by NIOT. Now this technology, you must have heard about it, that water boils at lower temperature at different pressure. Meaning, if you are thinking about, okay, water boiling requires 100 degrees Celsius. Now, water requires 100 degrees Celsius at 1 atmosphere. If you reduce that pressure or increase it, it will change. For example, in nuclear reactors, you pressurize that puppy. Coal power plant, you pressurize that puppy. And that's how you get very high temperature. Heck, in some Germany coal power plant, they are touching 1000 degrees Celsius steam. Like, how the heck it's 1000? Pressure, bonkers high pressure. So same goes here. But what if you reduce the pressure? Well, you can boil water at very low temperature, very low, like as low as like 24 degrees Celsius. You can easily boil it as long as you are pulling vacuum through it. So the idea is you utilize thermal gradient, basically thermocline of ocean. We have ocean. We are like, okay, what if we use ocean as a battery? Because if you look at the surface water, it always would be ambient-ish temperature, as in like 24, 25 degrees Celsius year round. But the moment you start to drop your pipe a bit lower, the temperature drops drastically. It will drop a lot by the time you're reaching 500 meters. So, and if you're going kilometers, it will start to become freezing water. So, and again, year round, it does not change. So the idea is you take water, basically your warm water, that is surface water. Then you take cold water, which you pull through a deep place. And based on the temperature delta on between of these two puppies, basically your hot water that is 23 degrees Celsius, 28 degrees Celsius, India, bit hot, and the cold water that is 12 degrees Celsius. And tada, you're gonna get water. Because again, you take water, you have a chamber, you pull vacuum through it, you dump water into it, water vaporize. But here's the deal, that vapor has to be condensed. If you do not condense it, it will fill up the vacuum. So you send it through what we call shell and tube condenser. In that condenser, the cooling water is ran there to cool it down. That's how you remove vapor, and output fresh desalinated water. You do not have to worry about it. And it proportionately, basically how much water it removed from the fresh water source, warm water source, it's very negligible. That's why when you send it out, it does not matter. Marine life does not get affected. It's negligible. And you have cold water, you have fresh water, and you have warm water. And here's the deal. If you want to do it with other things, like for example, this is using thermocline. But what if you are wise? What if you're like, hey, we have coal power plants. Coal power plants have cooling towers. What if you dump that heat rather than pulling basically warm water and cold water like too dry? What if you just pull water from here, surface only? You do save the energy on plumbing, so to say. So save energy on plumbing, pull the water that is 24 degrees Celsius, and now you heat it up. And how much heating you need to do? Barely 20 degrees Celsius heating, and you can easily do it. And water takes bonkers amount of energy to do phase change. So it becomes a perfect heat sink, and fresh water is the byproduct, and all that in one pipe. So basically it's a cooling tower in reverse. You get cooling and you get fresh water. India built this. Now everybody knew it. Every country knows about this. It's just that India had this NIOT, National Institute of Oceanic Technology, and they're like, okay, let's build it. We have a lot of small islands in India, Andaman Nicobar. Those are basically have growing population. How the heck you feed a population that is growing in an island? Ta-da! We don't have to worry about it. This has been working for years. We do not have to worry about it. It does have the penalty that it was made in India. We do make awesome things. We just don't document it. If you try to search about it, most likely you will end up with my video. So awesome technology, LTT. Again, I think India should really start to create a partnership with all the Middle Eastern country. It's like, bro, don't let Israel troll you with a reverse osmosis. Let us give you a cheaper technology. So LTTD, been working, no penalty. Nobody even cares about it. That's how good it is. It's like, bro, we built it, it works, go home. Heck, we really should start to move all our thermal power plants to next to coast, and then it's like, okay, waste heat reduction and more fresh water. Instead of power plants drinking water, they start to give water. Now we come to two good things. Now two bad things. Hydrogen scam. I have no idea how easily Indians keep falling for that. And again, in the name of progress, you can sell Indians almost anything. Now, why would it not work? Well, you have to know difference of certain things, specifically kilograms and liters, as in gallons and pounds. You have to know the difference between them. So, for example, if you want to sell you something, I'll sell that, hey, hydrogen has 3 times the energy content of petrol. Is that true scientifically? Yes. For example, if I give you 1 kilogram of hydrogen, that will give you up to 120 megajoule per kilogram. That is huge. How huge? Well, petrol and diesel will poop out at 30 to 40. So almost 3x the power. So is that true? No. Why not true? Well, kilogram is not how you carry something. You carry something in a volume, liters. How much capacity does it take? Like whatever the weight is, you still are constrained by space. So now you have to add basically mass multiplied by surface area, as in density. Then you take liquid hydrogen, the best you can have, that is only 8 megajoule per liter, meaning how much oomph you can carry in this tank, negligible. Compare this puppy to diesel. Diesel is like, bro, don't even compare. I'm 35 megajoule. What does that mean in real terms? In real terms, it means if you have a jet engine or a combustion engine that is converting roughly 28% efficiency, which mind you, big engines can easily cross 30% nowadays. You have to convert 100% out of hydrogen and you still will not be competent enough to compete. If I give you this much liquid hydrogen and I give you this much liquid diesel will beat it, no matter what you do. And again, if it's a good engine, like let's just say F1's bonkers stupid engines that can reach 51% thermodynamic efficiency, yeah, lol. And if it's a jumbo jet engines, yeah, lol. So again, we have known this, we have tried this. This graph is in every book. If you want to find its source, it's from Department of Energy in USA. And yes, there are other books also, other sources also. You can go YOLO on it. Every chemistry, hydrocarbon, fuel companies have this. It's been known. So that's the fundamental meaning. If you have to carry the energy, hydrogen is the worst carrier there is. You cannot utilize this as a replacement of diesel or petrol. It just won't work. We have tried even with jumbo jet. Soviet Union tried it. America tried it with fighter jet. We have been through this. It does not work. 8 and 35, non-comparable. Now that's assuming you have free hydrogen, as in like imagine a world where you drilled and you just got hydrogen out of it. Nobody would care. But we do not live in that world. We live in a world where you have to make hydrogen. Either you smoke cocaine and you're like, okay, what if I take methane, as in natural gas, CH4, and steam reform it and then get hydrogen? That's useless because again, might as well use methane directly. It's far more effective. Even rocket companies learned that. It's like, hey, let's just use methane, not hydrogen. So that would be stupid. And most realistic output is like you take energy from renewables and you dump it into water and you get electrolysis and then you get your hydrogen. Now, is that renewable? Sort of. Is that practical? No. You have multiple phase change operation happening, meaning the liquid is going to gas, gas is going to liquid multiple times. You are taking a gas and you're compressing it and transporting it. So the round trip efficiency is bad. Like no matter what you do, a round trip efficiency of a capacitor will always be higher than a cell. Why? One is handling it in electric field, one is converting chemical. By law of physics, it will be different. Same goes here. No matter what you do, a hydrogen system will not be efficient in terms of how much energy you are spending to do a work. So overhead wires, when you are talking about railway, overhead wire is the best. We classify as 1. So battery, what kind of percentage we are talking about? If it's a sloppily built system, you are still expected to get 85%. So that's good. Little bit of cost, but again, why would anybody build a battery train? Simply because there are a lot of branch lines. And what happens if you do smoke hydrogen? Well, 40%, meaning you are burning 2x the energy to do the same task. Now, battery trains are mature technology, as in like ancient, as in like if you have access to certain European museums, you will find physical hardware from a century ago. That's how old it is. And again, mining industry is like, you had other options. So fundamentally speaking, it's like duh. Battery trains, duh. Why? Well, because long ago we developed something known as lead acid battery. Now, here's the funny thing. Trains are one of the few modes of transportation that actually likes the weight. Like if you do not have weight, it will slip. heck, when we are building electric locomotive like in India, VAP series, those puppies were so light, you had to put giant ballast weight into them so it sticks to the track. So adding battery mass, it's like, sure to take money. So fundamentally, battery trains work. Japan had this issue where they had like main line, lot of traffic. They electrified the whole thing. GG, awesome, have fun. But here's the deal: they had a lot of branch line where trains were not that frequent. Like they had one in morning, one in evening. So that was not logical to electrify. Electrification is costly. It has very high capital cost. Same happens in Europe, same happens in India. So Japan was like, hey, what if we made sort of hybrid where we have a pantograph, and if you are on electrified system, it's a pantograph system, slowly charging the battery. When you are going into those remote line, pull down the pantograph, it's a battery train, go YOLO, come back. And again, because the distance is fixed and rolling resistance of a metal wheel on metal tracks are negligible, it's super efficient. Oh, and not to mention, you also get regeneration. So fundamentally, old technology, this I think is the newer model. This has been 15 years older, and they had a model like almost 20, 25 years they have been working this. Again, even Italy has one of them from Hitachi, and this is UK. They had brain. How the heck they got brain? So they had the idea where it's like they're going to put 3 foots, basically third rail, so to say, 3 of them. One is the positive, 2 of the negative, or something like that. The idea is train is going and train is returning. They never have to do polarity change. So that's how they're going to have 2 feet and they're going to have a dump system. And to dump energy into that, they will use fast charging. Now, if you understand fast charging, you will understand that will require a lot of oomph. So the idea is they're going to have 2 battery banks. One battery bank is in the train, another is on station. So if they are connecting a remote location which does not have a lot of grid connection, they will slowly trickle charge it over day. And when you have the train, it's like dumps it. So they can even add solar, small wind turbines, all of those things they can add it, even a small generator as a backup, and then it slowly charges it up, and train comes in, bams it. Now, wouldn't that shorten the lifespan? No. Whenever you're talking about battery is not a dumb thing. It's a tailored recipe, meaning if you want kilowatt hour for a case of electric vehicle, you will have certain type of chemistry. Like you can have nickel metal, nickel I'm saying. You can have basically lithium, lithium iron phosphate. You can have lithium LTO, lithium titanate oxide. You have a lot of other options. And nickel, cobalt, manganese, you have a lot of options. Based on that option, you're going to get either a lot of capacity or a lot of power. In this sort of system, they look for power. They do not need a lot of capacity. You do not need a lot of kilowatt hour, but you need a lot of oomph. So it's a known system. Now, then why didn't India invested into that rather than investing in hydrogen? Well, these things are known thing. Like they are sorted. They are like you can pick up a phone. There are at least 5-6 companies that can bring you. Meaning there is no pricing lol, where you cannot just ask whatever money you want. You have to be reasonable, right? Because there are multiple companies, so you can't charge whatever you want. But if you smoke something and you are like, hey, what if I smoke hydrogen? Then you can charge whatever you want. We have toy train that cost more than the main line 12,000 horsepower systems. A toy train that costs more than 12,000, like a narrow gauge versus a broad gauge. Yeah, that happens. Again, hydrogen allows you to do this sort of scammy things. So fundamentally, everybody likes it. And again, the company, I think Armstrong is the one of the primary subcontractors, so to say. They smoked Germany with that. Germany built the train and they ran it, and they were like, dude, this is so stupid. It would be better to run into battery train. They switched. They started in 2020. They smoked, and by 2022 they shut it down, rolled back to battery system. I'm like, we could have used battery directly. So, and again, all the subcontractors that were providing the fuel cell, India is buying it now. We're gonna have to shut it down because again, the best thing, battery. Next best thing, just electrify the damn thing. So, and again, toy train route is that is a scenic route. You can have this thing, so you do not have pantographs and uglified and all that. All of that can be done. So, fundamentally, who benefits from this? Well, OEMs, original equipment manufacturer, they pocket the chain. Because again, when you are talking about something that has a lot of competition, profit margin is tight. When you're talking about something there is no competition, you're just like, let the money come in, and all the producers, they become rich. They're like, GG rich. So that's awesome. And again, train is the only one of the few modes of transportation that loves the weight and track length is fixed. So we fell for this scam. And again, the hydrogen is tragic. It's like it has been falling for so often. It's sad. It's like America, 1930, we built a fighter jet on hydrogen. It's like, yeah, it's stupid. They were also trying to put a hydrogen in buff. And they were like, yeah, that's smoking. Then Soviet Union, we built a jumbo jet on hydrogen, and it was stupid. And then now Airbus is building. And again, Airbus is not building it. European Union is forcing them to build it. And it's going to go through the exact same route. 35 can't compare to 8. So it's a very sad thing. And again, Indians are supposed to be good at mathematics. Now we come to the solar on track, and this boils my blood. It's like, I get it. Hydrogen does require you to know the difference between kilograms and liters. It does need you to know like what is the importance of round trip efficiency. It does need you to know that how the heck a market works. So it does require a little bit of horsepower. Like 5 minutes of thinking is required. Solar on track, how the heck Indians fell for this? Like railway has large surface area, like bonkersly large amount of what we call platforms. India has like huge railway network. And again, let that be very clear. Our platforms, we don't have one or two in one station. Some of them, lot of them have 10 plus. Some of them have 22 plus. So we have bonker surface area, meaning people can go there, lay out solar panel, align it to the sun without too much hassle, and we have not covered even 10% of it, so to say. So, and again, railway does need power. Heck, it needs electrical power. Heck, we can literally have what we call grid tie inverters and dump the energy directly at that point in time into railway's grid without any hassle. So railway has a lot of surface area and needs a lot of, but so what does solar panel need? Solar panel needs to be facing the sun. You cannot have it in place where it's not directly looking at the sun. It loses efficiency very drastically if you do not make it look at the sun. Basically, it has to do a steering contest to the sun and perpendicular to it, meaning something like this. It has to be perpendicular. So fundamentally, it has to, that's the first requirement. Second, it hates partial shading, what we call partial shading effect, meaning if you have a electric pole and it's casting shadow on any of the panel, that panel will be kaput. You're like, why? Well, solar panels, if a cell is shaded, it's acting like a resistor. It's bringing down the whole panel. That's why modern panels have cut line, which we call half cut panels. The idea is that one panel has two sub panel, so both of them are in parallel. So we have to do that. And again, when you are talking about train tracks and all that, yeah, you're not going to get a lot of electricity because most of the time panels would be bogged down. Again, that's an electrical level. Another aspect is, that's why that location is so bad. Micro cracks. What is silicon panels made out of? Silicon crystal. What is crystal susceptible to? Fractures, cracks. Meaning, when you have going train tracks going like this, kaput kaput, if you look into basically a railway track, whenever weight is going through it, it does suppress, then it bounces back. That's why it bounces back. So, and again, that's happening every axle. So it will crack very quickly. And again, let that very clear. Crack will not be like kaput, it cracked. Crack would be more like micro cracks, and over 2 years of time, rather than 25, it will lose all its output. So, and somehow we are deciding to put that on. It will not last long. And not to mention, I'm not even talking about dust, garbage, or the horrifying thing that these trains have axles which have grease and oils and stuff. Who the heck came up with this idea? So, fundamentally, and again, first cover all the surfaces area that you can easily cover without any hassle. Take care of those puppies now first. Take care of those puppies. Then worry about putting something in between the tracks. But no. And again, I have no idea how the heck we are convinced somebody and how the heck news channels like, this is awesome. It's like, and guy was giving numbers. It's like, okay, what if we cover 1 kilometer of it? And again, India does have bonkersly large railway network. So 1 kilometer will give you 800 unit. I'm like, no, it won't. It won't. And even if it did, like perfect condition, even if it did, it will be very short-lived, as in like months, not annually. So fundamentally, this is a bad idea. So how the heck people fell for this? Well, fool's glory. Somebody looked into European system and looked at the graphics and all that. Like, whoa, it would be awesome if we did it. Remember the solar roadway BS? People burned billions on it. Same thing. And again, for the people who are doing the servicing, they are printing money. It's like, hey, you are making a panel which is going to kaput itself in 2 years. We're going to sell you more panels. Recurring customer, subscription. They're having fun. So fundamentally, this is tragic. It's like, how the heck, why the heck we never do any sort of market study or any sort of research? It's like, oh, hey, this people did it, this people did it. Why did it not work? Oh, this is why. It's like, you know, if you want to do research on hydrogen, you have hundreds of projects. Why it did not work? They never do it. So, and again, everybody, whoever wants to criticize it, they are like, oh, you are against progress. You are the reason why India is not progressing. I said, like, balance of intelligence is not balanced in India anymore. So that's the tragic part. Like Indians, as an Indian, we should know sun, how the heck that works by default. Heck, we are going YOLO on solar. Heck, my rooftop has solar. This was truly tragic. It was like, really? Really? So this was my presentation on basically how India has like some great technology and some great scams. So I hope you have liked it, learned from it. In that case, please click the like button, share it amongst a friend. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.